two velocities here. Now, I have to say, this is a very complex situation, okay? But we'll give it a go. Now, I'm going to make the velocity of the rain high enough. We're going to do two scenarios in our head here. The first scenario is basically the velocity of the rain. We're all assuming rain is going downwards, okay? Ain't going upwards to begin with anyway, I can tell you that much. Now, for argument's sake, let's say that it goes 3 meters per second to the right, 4 meters per second down every second. So velocity of the rain is simply 3I minus 4j. Just making up these numbers at the moment. Now remember, the woman is reporting on the rain's velocity. So it's velocity of the rain, how it appears to the woman, which is Vr minus Vw. Okay. The next thing to remember is it makes an angle of 45 degrees with the vertical. So if we were to do this like so, where the rain is coming in right to left, so positive I value, negative j value, okay? So that means that it's going to be coming in to the woman at a certain angle, okay? So here's what we're going to do next. We're going to do the velocity of the rain relative to the woman. So the velocity of rain is 3I minus 4j. Minus the velocity of the woman, and the velocity of the woman in the first case scenario is minus 5j because she's dropping down 5. So that'll be plus 5j. In this case, the velocity of the rain relative to the woman will be going 3I plus 1j. Is that okay? Now, if you were to run the second scenario, however, velocity of the woman is minus 3j. In this scenario, the velocity would obviously change its direction. It wouldn't be to the same vertical, okay? So I'll give you another example here. Say this was instead of playing plus 5, it's now plus 3 for scenario 2. That'd be a minus 1j, which means it'd be going in a different direction to the vertical, okay? So what we're sort of assuming here, and once again, nothing to do with the technique for the question, is we're assuming that this value for j, the j value of the rain, is going to be a relatively large number. For argument's sake, I'm going to take 7 as an example. In this case, the 7j, it won't change direction because the j is large enough to cover it. So minus 7j plus 5j is minus 2j, and we can see that that's negative. Okay, and then the other one would be, if that was plus 3j, for example, instead of the minus 5j, it's the minus 3j. We're still seeing that the second velocity of the rain relative to the woman would be minus 4j. So it's in the same direction to the vertical both times. Okay. Now, key thing to remember about the vertical is that if I was to draw this out, 3 across, 4 down, remember that that'd be a 3 here and a 4 here for scenario B. And for scenario A, it would have been, what's a 3 across, 2 down. So something like this. Now please remember, it is a minus 4 and a minus 2. Okay, you got to be very careful of that. Okay, so when you're calculating the horizontal angle is what you can calculate first. When you're calculating that horizontal angle, you need to multiply the j components by negative. So you can tan inverse 4 over 3. You find out that the first one is 53 degrees to the horizontal. I'll just round off, which is 37 degrees to the vertical. Now remember, when you decrease your that's a slower ascending speed. So when you increase your ascending speed, as in you're dropping faster, look what happens. When you're dropping faster, you're now going to multiply the minus 2 by minus, so you're going to get tan inverse 2 over 3. And this will be 33.7, so just call it 34. And once again, you can see that 34 plus 56, you can see that the angle should be bigger. The faster speed has a bigger angle to the vertical, while the slower speed has a smaller angle to the vertical. So we're expecting a scenario quite like this in our question. Okay, so the first thing we're going to do when setting up this question is we're going to set up our parameters for the rain. Now the velocity of the rain in my case will be this. I'm going to call it xi plus yj. Now I can tell xi plus yj, very easy. Now x is positive, so we're expecting an answer like 2, 3, 4, 5, 6. Well, y, even though I'm putting it down as a plus, we know that the y is negative. Okay, that y is definitely negative because it's going downwards. Okay, so it's x here, y here, and that's the initial velocity of the rain. Okay, we once again engage with the same one. Velocity of the rain relative to the woman is the velocity of the rain minus the velocity of the woman. Therefore, the velocity of the rain on its own must be the velocity of the rain relative to the woman plus the velocity of the woman. Now, what we're going to do next is we're going to run the scenario. We don't even actually need that as it turns out, but we're going to run this scenario here. Velocity of the woman is minus 5j. Okay, so it's xi plus yj, take away the velocity of the woman, which is minus 5j. So what we got here is xi, and then we got y plus 5j. Now we know that's going downwards more than likely, so the y value is going to be bigger than 5, okay? So it's going to look something like this. Here's the rain, this is the rain relative to the woman now. It's not the same diagram as this one over here, okay? The x component stays the same because it's not affected by the parachute is going up and down, so going descending directly down. However, the component, the vertical component, is y plus 5. Now please remember what we did in our previous question. We know this is negative, okay? So although this is 45 here, which is to the vertical, that makes that 45 here. So what we're going to say is that tan 45 has to equal, now we got to multiply this by minus, so it's minus y minus 5 all over x. And then we know tan 45 is 1, so we're going to get x equals minus y minus 5. And then we're going to get x plus y equals minus 5. Okay, that's our first scenario done and dusted. Now, in scenario 2, we're just going to reuse this information here. In scenario 2, the velocity is minus 3j. So what we simply do is we go down here and we adjust our maths. Instead of minus 5j, we're going to have minus 3j. And instead of y plus 5, we're now going to have y plus 3. It's no longer 45 degrees anymore. It's now 30 degrees, which in turn makes the horizontal 60 degrees. And then it's no longer y plus 5, it's now y plus 3. Once again, please remember your y plus 3 is negative. So we now say tan 60 degrees is your opposite minus your opposite over your adjacent. So it's minus y minus 3 all divided by x, which is, we don't know x yet. Now we know tan 60 is root 3, so it's root 3 equals minus y minus 3 all over x. Root 3x, and then you're going to add on the y there, so plus the y equals minus 3. Now we got two simultaneous equations to work with. Okay, so I'll bring this one down. I'm going to multiply this one over here by minus. So it's going to be minus 1x minus y equals plus 5. And we're going to find out is our x value, which is going to be root 3 minus 1 times x equals 2. And now we're going to divide 2 divided by root 3, take away 1. And what we find out is x is 1 plus root 3, or 2.73. So x equals 1 plus root 3, or 2.73. Next thing we're going to do is find out what the y value is. Okay, so what is the y value here? Well, we know that x plus y equals minus 5. So y must equal minus 5 minus x. So y could be equal to minus 7.73. Or y is equal to, we put this into the calculator very quickly, minus 5 minus what x is. So minus 1 plus root 3. Okay. We get minus 6 minus root 3. Now that's negative as we're expecting. Okay, so we go back to the top. This one here is 1 plus root 3. This one here is minus 6 minus root 3. Now, if we tan inverse that, well, I'm going to multiply by minus 1, remember? So make sure it's positive. So 6 plus root 3. So tan inverse 6 plus root 3. Press the fraction button first, Mark. 6 plus root 3. And then divide that by 1 plus root 3. And then what we should get there is 70 degrees, so 70.54. Now if you look at the marking scheme solutions, it says 19.46, because if you take away from 90, it does it to the vertical, so it's 19.46 degrees will be the angle to the vertical, if you want to go that way, or 70.54 degrees to the horizontal. Now I'm going to do Pythagoras' theorem next to find out what is the actual velocity of the rain. So we're going to calculate what the hypotenuse is using Pythagoras' theorem. So we're going to get 1 plus root 3 squared. You all know what to do with this. Plus, obviously done the hard part already, so plus you can use the minus or the plus if you want. I tend to use the plus. 6 plus root 3 squared. So there's your 43 and 14 root 3, square root your answer, and you get an answer of 8.2. So your velocity is 8.2. And that is you done. Very tough question, 2015 2B.